Well, good morning. I don't know many of you out here. I've been working in the energy world for a long time, and a lot of my efforts have been with manufacturing facilities, a lot with food, the final end product manufacturers, including ADM, and then also the automotive world. But how many of you out here have something to do with managing energy at a facility or facilities? All right, see some of my favorite people out there. I want to do this presentation. It'll be a little bit different than what you had before, and probably because the last presentation about all the rules and regulations with the EPA, I came from a background of working in nuclear power. I was a reactor engineer for a nuclear power plant, and I worked there for 17 years. And so I feel that burden of all the regulation and the rules, and it can pull you down, and you can just feel bad just looking at the list. And so after that period of time, I was about 40 years old after working in that field for 17 years. Thankfully, my plant was the oldest plant in the country, and it had to be closed just because it was old, and it was shut down, and that gave me a chance to start a new career. And I finally found out what I wanted to do when I grew up. So I discovered this job called energy engineer. And where else can you have a job that you save people money so they like you, you reduce pollutions to the world, and you can collect 4 million frequent flyer miles to give to your children so that they can go on vacations and stuff because you don't want to anymore because you're traveling too much. So that was what I got to do, and I've been doing it for since 1996, and it's just been a really exciting adventure. And what I'm going to talk to you today about is a step in that adventure. I left the nuclear world. I started as an energy manager for a number of corporations and started my own company, which now is based out of Central Mexico, owned by Schneider Electric. And I just sold my company, and a period of time came, and I was sort of there. I'm done with my company. I'm teaching at the University of Texas, and this headhunter knocks on the door and says, this company called ADM is looking for an energy manager. They were told that they should have a corporate energy manager and not just ones for each of the plants. I didn't even know what an ADM is. So you can take that to many of you, that's probably a really common name because of the field that we're in. Well, I investigated a little bit, and I started learning about ADM, and I went to visit the company and said, wow, this is a challenge. They spend $1.5 billion a year on energy. They have cogeneration plants. They have electric plants. They have plants all over the world. They have complicated systems. I said, this is an exciting challenge. So I'll tell you, that's where the story's going to start today. I'll tell you a little bit about my challenge and some of the things. What I hope that you'll get out of this is just some ideas that you can take back. Not specifically, I'll give you some specific ideas about equipment, but more, I found that energy management or doing improvement is a lot more about dealing with people and dealing with change management than it is about a specific technical thing. And when you get the change management and the dealing with people down and understanding that a little bit better, the program success or the amount of savings or the improvements go better. So first I'll talk a little bit about same thing I had to learn. I'm in this story. I come to ADM. I don't even know what it is. Well, here's some just numbers. Sometimes it's fun in these conferences just to see numbers that you might not see elsewhere. And many of you have grain and processing material that may even be traveling to the ADM plants or other companies like ADM. But here's some things that were like overwhelming to me. 1,700 barges, 26,000 rail cars. But here's the number. I put this thing on the side, 30 million gallons of diesel fuel. This was the fuel that was going in the barges to push grain up and down the Mississippi River. To put that in perspective, I used to be the corporate energy manager for Delphi Automotive. They had 300 plants around the world, 200,000 employees, and approximately the size of General Motors. There was more spent on the diesel fuel moving up and down than the total energy of all of Delphi Automotive in the world added together. That is a lot of energy to push something. And then you think about it, it must be a really big savings too, because barges are one of the most efficient ways to move stuff. So in a way, if they're spending 30 million gallons, it's doing a lot of savings too, because using rivers versus trucks and the other things. So just numbers like that were quite astounding. And then when we got down to the next part, I was overwhelmed. And I'm listening at the table this morning and last night, and everybody talks in hundredweights, and they talk in bushels, and bushels per hour, bushels per day. I spent my whole year in engineering, and I have a lot of thought in kilowatts and other things, but I never thought in bushels. And it's just not something that I was common to think about. But these numbers were overwhelming, and it adds up to here about 7 million bushels a day being processed. And as you know, that's a lot. It has to come all the way from the fields, be processed, put into storage, retransported, brought to the factories, processed into something new, and then shipped out in this continuous process that goes 7 days a week. That is a lot. I was giving a presentation at the Yale University last year, and the professor added this little thing in the bottom. He said, that amount of oil coming out of the oil seeds, as a group, all that oil, produces more oil than one of the largest refineries in the world in Saudi Arabia. It's hard to imagine. There's that much, and when you think of the little seed and all the oil that comes out of that and how much there is in doing these large volumes. But anyways, another term on here in the wheat portion, that's enough to make 90 million loaves of bread a day. That is a lot of bread. So this whole thing, these are sort of gee whiz numbers, but it's overwhelming. And then I get to the factory, and they say, we have pumps, we have air compressors, and one of the things that impressed me most in Decatur, Illinois, where they have one of the factories they call bioproducts, inside of there they have a room that has air compressors in it. And I studied a lot of air compressors. I've been doing detailed studies for over 15 years on air compressors, and I go into this room, and there's 23 air compressors. Each one is 4,000 horsepower. Imagine that, 23 air compressors in a row, each one is 4,000 horsepower. There was more energy going into that room to run the air compressors than the nuclear plant that I worked at. A nuclear plant I worked at wouldn't have been able to power that room. That's crazy. And that was just for a single product line. So the volume that food processing makes, other people, automotive that I was in other factories, think they use so much energy. I think people really don't have a good understanding of the vastness of energy that's involved in the whole food market from the very beginning to the end part. Well, I was overwhelmed. I got tours of the factory. I took the job, and then I arrived there. And the first thing I do is they have a table, and this is pretty interesting. Here's a table, and it only has one chair on one side and 6 chairs on the other side. And they invited me to sit on the one chair. So I thought, oh no, this doesn't look very good. Well, there's vice presidents sitting on the other side from each of the different divisions. And the primary answer is, what are you doing here? What experience do you have? And I could say, I did a lot with Tyson Chicken, analyzing their farms and their processing. And right away, one of the people asked, we are not a chicken company. And I could just feel the pressure. I could feel how they're thinking, here's this guy coming from another place. He doesn't know about our process. We've been here since we were 18 years old. All of us. For a long time when I was in ADM, whenever I would be in front of a group, I'd say, I know all of you guys have more years than I have months with the company. Sometimes it's more years than I have weeks with the company in the beginning. There are long-term people who are steadfast in the ways and a lot of experience, a tremendous amount of experience. So what can you do when you've already been working at this field for a long time, you've been running your plants the best that you know how, and you're doing a good job, and then someone's going to come along and try to say, well, there's got to be more to do, otherwise I wouldn't have a job. My job is to find more things to do. There's got to be out there. I don't know what they are yet. And then the group is saying, well, the energy is everybody's business. We don't need a corporate manager to do it because every plant has to do it. It's our biggest expense next to buying grain. So just have to listen to that for a little bit. And so I made a little slide. So here the group is telling me that, look at how we've been doing with energy over time. We've just been peeling it off and doing a great job upgrading and making our plants more efficient. So I have a saying to that: the barrier to great is good. You think that if someone or a group or an individual or a plant manager, it doesn't matter what level, it can be an individual person or going out, if they think that they're doing good, it's a lot bigger challenge to get them to do better. Okay. As part of this meeting, I got to meet a couple other people. The first one is a formula that was put up by who now is the CEO of the company. Do any of you recognize this formula from school? So at this time, he's a COO of the company, comes in and says, here's my rule, and he goes up on the board and writes it. Results does not equal no results plus a good story. There you go. I mean, I'm the new guy on the block. I have this pretty important position in my mind, and the COO of the company, who's just been there a few months longer than me, he puts this up on the board and sits back down. He doesn't have anything else to say. Well, not to let it go further, Craig Huss, the next person who's got a lot of years with the company, a lot of experience with the company, he says, I got a rule too. Patience is not a virtue. So which means hurry up, let's get lots of savings. And so, being in my own way, I went up on board and I said, I have a rule too. Let's resource according to value. That means if I find something of value to do, we're going to have the resources to be able to do it. I don't want to have what we call credenza, where beautiful reports, studies that says here's what you could do to save. We either resource it or we don't do it, but we need to be able to resource according to value. So these three rules stuck for my time with ADM, plastered all over the company, on walls, on the boards, in the newspaper, on the screen when people turned on their computer screens. I wanted to understand some of the rules and what we're going to be going after to make the program grow. But also, what could I do to everybody to tell them that what you're doing isn't good enough? They already had a plan. The plan at this company was reduce energy by 15% by the year 2020. So 15 by 2020. There already was a plan, and they were charging down the thing. You saw the graph going down. So what could I add to offer? What else could we do without saying like an insult? You're not doing a good enough job. You're not doing it. Here's what we're going to do beyond that. So in order to do that, I drew this little triangle with the solid blue line. This is where they were going. It doesn't matter. You can take this to an individual plant, an individual place, or an organization. This is aligned where you're at. What can we do to improve it? Well, if you're going on this line and we resource it better, we plan better, we could shrink the time up and we could get it done a little bit faster. Or during the way, we might add a few new ideas that you didn't have, and we'll add those on top of what you're already doing and get a little bit better things. Well, see the little circle with the dollars? Instead of getting it done by 2020, here we're starting at 2011, instead of getting it done by 2020, what if we got it the same goal, but we got it done by 2016, 4 years early? That would be that difference, the difference between the dotted line and the solid blue line. That difference in the big company is worth $250 million. So here's how I did it. I said, I got $250 million potential that we could have. So we need some money to make it go, but we have that. We can get that by accelerating and through bringing lots of examples of how projects, how ideas can be done faster. Instead of taking a year to do a project, get the project done in less than a year. Taking a long time to make a decision on a project. Maybe saying, well, this guy, my thing is resource according to value, not according to the engineer's calendar. Lots of times the engineers will have jobs. Here's all the things I'm going to do next year, and they lay out the calendar, and there's a good job that isn't going to be done till the next year because his calendar's already full. What does that mean? You don't have enough resources. If it's a good project, it needs to be done now, because every day a good project's not being done, it's losing money, especially when it's in a savings category. When I worked with General Motors, as the energy manager, I had a clock in the front of my office, and it clicked down the money that's being lost by projects that are not being done. That got a lot of attention because once a savings project is defined or identified, as long as it's not done, that money is being lost. And that number got to be very, very large. But that gave some motivation also. Let's not get that number large and not publish how much money we're losing because we're not doing something. On this slide, I have some keys too, and I highlighted one of them. One of the things I found, and maybe it is with some of your companies too, is I found inside of ADM anyways, a very strong thing that we do it ourselves. We make it ourselves, we fix it ourselves, and it's almost an embarrassment if we have to bring somebody else in to help us. And that's a good spirit to have, and I'm that way too. I'm a real do-it-myself kind of person, and I like doing stuff myself. But when we're talking about time, and we all have a limited amount of time, or we have a limited amount of experience, I found that we can get some things done better by bringing in some outside people to help. Finding experts. Outside here in the room out there, there's a lot of different companies who have really specialized in different areas. I find that a lot of the experts are suppliers. The reason they became suppliers is because they were experts. They developed these companies because they were so good at what they were doing, they were able to develop a company from it. So using experts to help me get my job done, because one of the things when I came to ADM, I got a really nice office, I got a place to work, but I looked behind, and one thing that didn't come with the job is this big staff. So there wasn't anyone to go out and give all these directions to, and so that was a necessary part. It's a big company. How are we going to get a lot of stuff done without staff? So there was another thing that helped. I didn't have a staff. I wasn't about to go ask them, I need some money. You just gave me the job, and I wasn't about to go ask them for, I need to have a dozen people to work for me before I can do my job. But one of the things I knew how to do is leverage utility incentive funds. And here's just an example of one. Utility incentive funds, a lot of the utilities have programs where if you do energy projects, they'll help you fund the projects. And they're not really helping you fund the project because you funded them. ADM, for example, is paying this added price on all their utility bills. That every utility bill had an added line that had a price for these utility riders, and it's the money that the utility company would put into a hopper, and the only way to get it back out was do energy projects and apply for it in their rules. But you could get it back out. And I looked how much we were paying, and it was a really large number. And I said, I want to get that money back. I don't want it to go out to support all the other people out there. So we applied for all the money that you could get back. And you can see as we started applying, the graph went up. And in the last couple years, this graph's a little bit old, we're returning between $7 and $8 million a year from utility funds. Imagine if you have $7 or $8 million a year. Now I can look behind me, and I have this great staff. So I was able to use funds from this program to bring in the people that I knew were the experts. We had a lot of pumps. The company has a crazy amount of pumps, 80,000 horsepower pumps per corn processing plant. And that's a lot of pumps. Well, anyways, I knew this guy that the only thing he talked was pumps. He didn't talk English. He didn't talk anything else. You call him up in the morning and say, "Hi, Mike." And he'd say, "I was thinking about pump number 7, and the frame is this. And if we were to change the impeller to this many degrees, we could reduce the energy for that pump and stuff like that." So I said, "Mike, you are the guy that I need to have. How would you like to come to this plant that just has pumps everywhere? And you could just go anywhere and just start finding savings." And he's been doing it. We almost kept him full-time employed for quite a few years as he started doing evaluations of pumps. Used the money from the incentive programs to bring this expert. Another expert was a fan expert. He loved fans, and he could go in and look and find out fans that aren't operating good and fans that aren't operating correctly. And so he helped us identify those, and so we could get a list of fans that we could correct. And we did it for fans and pumps and air compressors and heat recovery opportunities and control room systems to optimize what the control room operators were doing and what they were looking at so they could find more savings. One of the things that now I have my thing. I have the people, I have money, I'm ready to go. So we got some things to do. What do you do for improvements? I'm not going to be able to build a new corn plant. I'm not going to build a new oilseeds plant. I'm not even going to be able to build a new elevator or a grain milling plant. But what I could do is find some improvements, because I'm going to have to build some support. I'm going to have to get some confidence in what we could do. So one of the things that I go by is I have this little slide here. One of the principles of energy reduction is walking closer to the edge. You see the little guy moving along. Think out of the box, but do it intelligently. Try to think of new things that you can do, but don't fall off. I'll show another way to explain that. Imagine that you're driving down the road, and you know that the speed limit's 55, and you know that the policeman's there with the gun watching, and you look down at your speedometer and you have your cruise control set at 55. Are you worried about it? No. You just wave to the policeman as you go by with a lot of confidence. And you can have it set right at 55. You don't even have to be 54. You don't even have to be conservative. If you know it's right, that's it. But let's take the same situation and take your speedometer away. You think you can drive by with just as much confidence? You think you might be going a little bit slower just because you're not sure? Depends. I don't like getting tickets, so I probably would be going slower. Okay. Well, that's some of the things that I find as I've been studying plants, and it didn't matter what kind of plant it was. It doesn't matter whether it was a small plant, a big plant, or a giant corn plant. Challenging our set points. Why is it set there? Why do I need to have this temperature? Why do I need to have this flow? Why do I need to have this many amps on this motor? Challenging it and saying, is this just the right one that I need to have? We had a good example at one of the plants because they had a lot of cooling towers. And cooling towers are for cooling out their product. So you see these big cooling towers and you see the steam coming out. And there's 11 of them in this one place, so they're big cooling towers. And I was there in the summer, and all the steam's coming out. And then in the middle of winter, when it's freezing cold, all of them were still running, and steam was still coming out. And I'm wondering, what could be happening? Why, if I need 11 on the hottest day in the summer, why do I need 11 on the coldest day in the winter? That's just how we do it. They weren't really thinking about that. I go into the control room, and they said, well, we're trying to get the temperature of this process down to 75. And I look in the summer, and it's 85 degrees. So I asked the operator, why? Why are you running at 85 degrees when it says 75? He says, well, I can't get there. I can't get it. That's all the cooling that I have. I said, well, are you still making product? Yes. Is the product coming out okay? Yes. Then your set point is 85. It's not 75. So, see, challenging the set point, well, following that, if you drove down the road in the wintertime, you would see only 6 of those 11 cooling towers running in the winter. They didn't really need them all. They didn't need to get as cold as they thought. Okay. The end part is to have enough information to be able to know your set points and know where you're reading so that you can be able to show a before and after and show improvement. Managers or people who are going to give you money to do your next project are really impressed when they can see you have real proof. You can't say, oh, I'm using less energy. I hate those adverbs and adjectives that are out there, less, more, a lot. It's better to say, I'm saving $50,000 a month and here's the proof of it. Or I've reduced 100 kilowatts of load off of my facility and here it is. Here's the evidence. I did this and this went down there. That's where you build the confidence to do more stuff. One of the things I was trying to do is to get people to see that there's energy waste out there, even if you're doing a good job. And there was. You saw the graph going downhill. But every day we had to drive by a picture like this. What do you see when you look at the window? Look out your car window and you're driving. And this was at the world headquarters, so everybody that had anything to do with signing money or paying for money or wanting to save money had to see this. What I tried to do is get them not to be able to drive by it anymore without seeing dollars going up. So changing this attitude and changing the thing. Why is the white stuff going up? Because it's warm. There's energy inside. So one of in an oilseeds plant had a dryer. We took that's one of the right below that, the stack that has the steam coming out of it. That's a dryer down below it, and it's about this big around. You wouldn't believe how much energy that adds up to. So we just put this thing in. And this is a diagram, but I'll just talk you through it a little bit. What we did is we take the steam and just turn the steam, instead of letting it go out the stack, turn it into a tank of water and bubble it through the water. What happens when you bubble it through the water? The water gets warm, so the tank warms up. Now you take the warm water from that tank and run it through a radiator in front of the dryer and warm the air up. So the air gets warmer before it gets to the dryer so that the gas that's in the dryer doesn't have to run so much. So it's a pretty simple concept. It wasn't a complicated system. I mean, it's not, anything that you do in a big plant is complicated with pipes and things. But just in general, the idea is take the steam, bubble it through the water, get the hot water, warm it up with a radiator, use less gas. And in the middle, you can see 7.2 million BTUs an hour. That's 24 hours a day, 7 days a week. That's a lot of BTUs. I mean, a million BTUs of that is, right now the price of gas is between $3 and $4. So that's $3 and $4, $3 or $4 times 7, 24 hours a day, 7 days a week, just from a tank. It's not even an active thing. It doesn't use much energy except for a little pump to circulate the water around. Well, there was over 200 stacks that fit this category throughout the company all over. And places that had boilers, the same idea worked for even small boilers. So finding out places where there was energy going out, finding a way to use the energy. Some people were saying, well, we use this energy, but it's a lot hotter than the steam going out the top. Well, if you're preheating air, as long as you're warming the air warmer than it is outside. So if you have a 150 degree something, waste energy, and the temperature outside is 30 degrees, and you can warm it up to 150 degrees without having to use gas, you save gas. So trying to think that through a little bit, how many places have low-level waste energy, but we're still having to heat up air to bring it into a dryer, to bring it into something, and if we can preheat it up ahead of time, there's opportunity for savings. Here's another one. I don't know if it shows up very good, but that's a fan. Right there is what we call the sheave or the pulley, and there's a fan behind it. There is a lot of fans in the factory. How many of you have fans in the places that you work? Everybody. Fans use quite a lot of energy, and it's not much different than pumps. One of the things that we think about it is when an engineer designs something or builds it, what do you think the engineer gets in more trouble for if he builds it too small or too big? How many vote for it? He gets in trouble if he makes it too big. How about if he makes it too small? Okay. So what do you think most of your fans and things out there are going to be when they get all done? First, the engineer designs it, and then the other person sees it, and he adds a little thing on top of it. And then when you go to buy it, there's only two sizes, and so that might end up being a bigger one. Or there was one at another plant that we moved, and it's a little bit bigger, but that's close enough it'll work. What we end up with pumps and fans that have more energy than what they need to do the job that they're doing. So we'll go to these fans, and we'll find that the discharge or the suction side of the fans are throttled. We'll find something that's adjusting, or it could just be the resistance. You don't even see something throttling it, but it's actually the maze or the filters that it has to go through, and the fan's not operating as good as it should. So if you operate a fan what we call in the fan curve, it uses a lot less energy than when it's out of the fan curve for the amount of air that it's moving. And so bringing the right person with some very simple tools, some RPMs, pressure and flow gauges, sticking some holes in it, we were able to identify literally hundreds of fans that were out of whack and get changes like this. Almost everybody's pretty happy with a project. You spend $10,000 and you save $37,000. And this is at a place where electricity is only 3 cents a kilowatt. Imagine if you're paying more per kilowatt, how much it can be. Here's another thing that we don't think about too much in terms of is location matters. Across the U.S., we can see that in the Midwest, cost of electricity in general is cheaper than places like New York and California. We know that it's expensive on the East Coast, but it's cheaper in the Midwest. In some places in Illinois, it was some of the lowest cost in the nation, and across Iowa, it's still pretty good prices. But there's isolated places where it's more expensive. So in this study here, in this list, it's just, I took the names off, but it's a variety of elevators. And in a sense, because we were buying so much electricity and we had so many accounts, we had 5,000 electric accounts to pay a month. But inside of that, there's these elevators, and look at here. There was 11 elevator sites that were paying an average of 19 cents a kilowatt because they were with small co-ops or municipality areas, and because their electricity usage isn't real stable, isn't a flat line, they end up paying a lot more. So the rules are different. So projects that wouldn't work in one place would work in another place. So sometimes we don't think about that, and we say, well, as a company or as a corporation, we're doing projects, and we say, well, these kind of projects we don't do because, they don't have a payback because electricity is too cheap. But by isolating these out, these are target plants to work on. I'll explain that a little bit more in a minute. Okay, here's a picture of one of a elevator site. We had a lot of them, but they were kind of typically in a pattern like this. This would be the energy usage per month. And you can see there's a pattern. In January, it goes up, and then in the middle of the summer, June and July, is like the lowest period, and then it really peaks out towards the fall, and it has to do with how much grain is being processed at the time, and depending on what product it is and what the season is, it will be different. But the important thing is it's not a flat line. It's not just steady. Like a processing plant is almost a straight line sometimes. That's why there's all the elevators out there. They're holding it so that the processing plants can have a steady feed year-round. Well, in these places where the energy is used for drying and blowing and loading and unloading, it has a wide variety. Well, from an electric company's point of view, this isn't very good, not to have one that goes up and down. And then if we look at it even a little bit closer, we can see that it's not even flat on a given day or a given week. It's sort of like, we can work during the day and we don't work at night, or we don't work on the weekends and we do more work during the day because it still works out for us. Well, electric companies charge prices for electricity differently, and during the day can be more expensive than the night and weekends. So demand charges and how energy is being used, that becomes a tool. We're looking for tools. What can we do to help cut our costs? Well, one of the things we can't do is if we don't know what we're using or what's the pattern of what we're using, it's hard to determine what to do. So remember I said about the policeman and having your speedometer? Well, if you don't have your electrical interval data, which usually you can get from the electric company or some pretty low-cost meters, but if you don't have a way to look at your electric usage in increments and see what the pattern is, you can't actually see how much you're using, and then you can't compare it against the electric bill to see, well, what's the time of day charges? And what if I didn't do it during this time? Is there some things that I could spread out and do it at different times to lower the cost? And that's a tool that can be used. In a lot of these isolated sites, demand charges are really high. They can be 30 to 40% of the entire bill is just related to what we call demand charges. And so finding ways that what if I were able to flatten this chart and run some things a little bit different hours or spread them out a little bit so it didn't have a peak, there's a place that would reduce the energy. Another area, and this one is why I left ADM a year ago to start, because I really like cogeneration. I did a lot with ADM with that, but building small cogeneration plants. And cogeneration, what is that? That's making electricity and heat and using them both. When the electricity company makes electricity, it takes heat to do it. So there's usually a coal plant, natural gas, a nuclear plant. They make it, but they don't have any way to ship that heat that they make. So they just ship the electricity and they throw away the heat, either to heat the lakes or the water or big cooling towers and heat the air. And that heat doesn't get to go anywhere. So that's not a very efficient way to do it. So when you buy electricity, you buy it with most of the heat that was used to make the electricity being thrown away, and you get the electricity to your site to run the fans, and then you need the heat if you're drying and you're adding heat to it, so you buy more fuel. So electricity company threw away heat because they couldn't get it to you. You bought the electricity, and then you bought more fuel to do the heating to go along with it. And that's what this is. It shows you can have 51% efficiency about if you buy the electricity, overall efficiency, versus what if you made the electricity at your site, and since you were making electricity there, the heat that was normally wasted is also used for drying. So you'd have what we call cogeneration and use the waste heat from the generator to do the drying instead of buying new fuel for it. And so that combination comes out to be more efficient, uses less energy, and makes less pollution. So anyone that wants to talk about that more, I would be glad to. But that is an opportunity, especially an opportunity in the areas where there's higher priced electricity and a way to lower their costs. We're seeing that places that have the higher cost of electricity, this methodology lowers their overall energy cost by about 20 to 25%. That's a pretty good amount. When you're trying to reduce your cost, trying to come up with something that you can reduce your energy cost by 20 or 25%, sometimes is pretty hard. Okay. Another part that is, where do you get the help? I mentioned that a little bit earlier from my example. When I turned around, I couldn't find anyone in my office. I used a utility company. Well, leverage people. What I found, at least in ADM, and maybe it is in your facilities, there's not a big staff at the elevators. There's not a big staff at the mills. They don't have this engineering staff. They have people who are just like doing everything. They're the jack of all trades. They have to do the repairs. You have call-in electricians or somebody that helps, but there's not even a full maintenance staff in some of the facilities. It's almost called in for emergent work. And they've really leaned it down. So, and then everybody's there. I don't suppose. How many of you have yourselves or other people that just don't have anything to do and are sitting around half the day? That's what always happens. Not everybody raises their hand for that. Well, if the person's already busy, then how are you going to say, well, you should do all your other time, like your nights, weekends, and lunchtime, and go out and do analysis to find more projects? That usually doesn't work. That's why we don't get the projects. So what we try to do is leverage experts, and I always try to leverage experts where I didn't have to pay for them. I was willing to pay for projects when they're ready to go, but I wasn't wanting to pay a whole lot of money because it's hard to get money. To get money to find a project, you say to the boss, you say to the company, I would like $10,000 or $20,000 to go see if I can find something. I don't know about you, but I haven't had very much luck with that. So if you can find people who are more willing to do that. So I listed some examples. 2 areas that are really high value in the facilities are fans and blowers, and there's utility incentive programs. Utility incentive programs, some of them actually have engineers who have skills and are able to get equipment to do measurements of fans and blowers and do those tests to tell you if the fans or blowers are operating on their efficiency curves. The Department of Energy also supports programs. I saw one of your in the other group that's called JEEPS. Each year there's a assembly, and they write papers, and in there they talk about the industrial energy program. And a lot of universities, and they're in the Midwest, some of them, they have staffs that can come and do that. They only need a little bit of direction. If they had the staff come here, I want to have my fans measured to see if they're fans or pumps measured to see if they're in the efficiency curve or not, that's something they can help, and those are already funded. Another one is demand management providers. There's people who are looking to see if they can help lower your demand, and maybe they can even sell some of that demand that you could lower if they could find a way. So they'll come and do it. They call it demand response sometimes, demand management companies, and there's quite a few of those out there. People who sell variable frequency drives. And one way to adjust your fans to get them right, you can change the pulleys, but what I found is a lot of people don't want to have their fan adjusted because once in a while they got to have the full force of it to blow out something that's clogged or clean it out. And so they don't want to take the risk of slowing it down and then have to change the pulley back to blow it out. So a variable frequency drive can often be put on, and there's a lot of rebates to do with variable frequency drives, but there's also experts with pumps, fans, and variable frequency drives that can come in and measure your stuff and tell you. And of course, they're going to try to sell you that, but you're not required to have to buy from them. But if they try to sell it to you and it's a good deal and it saves money, then that's the way to go. Also for funding, sometimes we don't have enough funding. It's kind of hard to get through your company. So one of the process ways, there's the internal funding. There's a program called PACE. You can look it up, just those letters, PACE, energy funding. There's also utility incentive programs, as I mentioned before. It's your local utility has the programs listed. And you can look at a place called DESIRE, desire.org. So I didn't write it on here, but it'll show all the utilities and all the incentive programs available for your area. And you can zoom in. It's real easy to use. It's run by the University of North Carolina. And then the last one, I call it DBOOM. This is design, build, own, and manage. And it's one of the things that I work with is where companies will come in and they'll put in a cogeneration plant for you. They'll pay for it, operate it, and everything, and just give you the savings, and they'll keep it. You don't spend any money. The only thing you get is a savings in the end. You don't have to come up with any money for it. You don't take on the risk if they chose the wrong equipment. You don't get quite as much savings because they're going to take part of it, but you didn't have to spend the money in the beginning. Okay, I'm going to close up with this last slide, and it's just more of a teaching slide. It isn't specifically about an elevator or anything else, but it's a thing to remember when you're doing projects. People like to stay where they are. That's the current status, equilibrium. There can be incursions. We have to lower price. We have to have competition, new rules, regulations, and even incursions don't put us down. What we have to do is to go better, to get up better. We have some things. One, you have to have knowledge, skill, and resources. Because if you don't know how to do it, you won't do it. But the things I find that are most important are these two that are highlighted, desire and belief. Remember that when you're trying to convince somebody that you want to do your project. They have to have a desire to do it and a belief to do it, or they can find innumerable amount of ways to stop it. And that's what the little gray cloud is there about. People who will try to stop projects. But if they want to do it and they believe in it, so if you work that as part of your whole project design, when I want something, is getting people on board to believe in it, that's when it has a lot easier time to get through.